Workshop on layout and extraction, and it is open generally to the public, not restricted to Chipalooza Challenge members. The information I'm going to give is directly relevant to where the designer should be in the challenge, but it will be generally useful for anybody who wants to know about the analog design flow and has listened to the workshop about schematic capture and is ready to go on to layout. And I want to apologize to the people in Asia for the time. I know that some people have requested that we have these at a time that is more amenable to Asia. However, I do need a team of people from eFabless in support of the webinar, and to get us all together, it really has to be in our daytime. So again, I really apologize. It's just the way it has to be. And I will always be available at times on the Chipalooza channel in the Slack workspace for questions and answers. So you can watch the video and come to me with Q&A on the Slack channel. So as a reminder where we are in the challenge, we are now at March 27th and have gone through most of the key points of the challenge. And this is the layout and extraction workshop. And starting from today until layout is due is to April 15th, and that gives 21 days for layout and verification. And again, a reminder of why we're on such a constrained time is because there is a shuttle run that is going out on April 24th, and we want to be able to put as many of these designs on that shuttle run as we are able to. That depends. We obviously want them to be in finished condition, so we will take those that are ready to go and put them on the April shuttle. So, goals of this workshop. I want to introduce you to the main open source layout tools, Magic and KLayout. The design groups are in all sorts of stages, from people who have probably never used the layout tools before to people who are intimately familiar with them. So I will try to cover all bases, knowing that 1 hour is not enough time to cover all bases for one of these tools, let alone both. So I will point you to where you can get information and give you the basics and let you loose on your own. I am the developer and maintainer of the Magic layout tool, and that is the one that I am by far most familiar with. So I am going to, in a way, give short shrift to KLayout. It is not because I think KLayout is a poor tool, it's just because I am not as familiar with it. They are both great tools, and they are both useful in their own ways. They both have strengths and drawbacks, and I'll try to give you a little bit of a comparison on why you might or might want to use one or the other. Also, how to convert a schematic netlist to the initial layout. That is the most important for the Chipalooza Challenge participants. They have got their netlists in either ready condition or close to it, in most cases, and are ready to get it into layout. And I do have a method in Magic for going into an initial layout. I do not have a method for creating your layout automatically. There are various tools like Berkeley Analog Generator or FASOC that can do similar things. There's something called Align. You're welcome to play around with them if you are familiar with them. I would not suggest trying to learn one of those tools and ramp up on it in the space of a few days. All of the analog blocks for the Chipalooza Challenge are relatively small and it is feasible to do them in the space of a few weeks with manual layout. And part of the creation of a new layout is how to deal with parameterized devices. And so I will show how to create and modify parameterized devices and how to do parasitic extraction. Now, this part of it may get we may end up at the top of the hour before I even get to this. If so, then I'm going to bump this into the next webinar that's coming in 4 days. And say a little bit about what are layout best practices, and then say a few things about specific layout requirements for the Chipalooza challenge. So, introduction to tools for layout. I am going to come out of presentation mode so I can jump back and forth between the presentation here and my desktop, and so I can show you a few things live. So, first tool I want to introduce to you is Magic, and the best place to find the information about Magic is my own website, which is opencircuitdesign.com. And if I go to opencircuitdesign.com in a browser, there is a menu over on the left-hand side that takes you to all the tools that I maintain or develop. And one of those is Magic. Click on Magic, and the main things that you'll need to find there's a page for how to download it, how to install it, and how to use it. Those are probably the 3 main pages that you'll need to know. In particular, the page on using Magic has information on how to invoke it from the command line, which I'll be going over live in the webinar, and also a command line reference for all the commands that you might need to type on the command line, and a set of tutorials. These tutorials are older and a bit out of date. I think if you want to look at tutorials, I'll be showing you where to find video tutorials if you want something that is a bit more up to date. For KLayout, the website to go to is klayout.de. And from here, the top bar will tell you how to get it, how to install it, and the about gets you to the documentation, and there are plenty of tutorials about this as well. And for those of you, in the last workshop, I mentioned that in order to get all the schematic and simulation tools, one good place to go is the GitHub IICJKU. That's Johannes Kepler University, where Harold Prettel has 2 tools or 2 repositories. One's called IIC OSIC Tools, which is a Docker container solution that if you get that Docker container, it will give you all the tools immediately at your fingertips. OSIC multi-tool is not a Docker container, but it is a set of scripts for grabbing and installing all of the tools on a standard. I think it's based on Ubuntu Linux, so it worked on Ubuntu and Debian, presumably. And either of those will get you to the tools that you need. If you want to compile and install Magic manually, it is a matter of going and doing a git clone from my GitHub repository, which is here, github.com, r_Edwards/magic. And once you have cloned it, you can cd to that, and it's a fairly standard GNU Unix type configure and install, configure, make, and make install. And the instructions are on the website as well. KLayout is a bit easier to install if you're doing it manually. The KLayout developers have a nice team of people who are constantly getting it ready for distribution on Linux packages. So all you really need to do, and say here for an Ubuntu system, you would just do sudo apt install KLayout, and it usually gets you something that is a pretty recent version of KLayout and should be good enough for the purposes you need. So a little bit about Magic. Before I start actually demonstrating how to use Magic, just give a few words about what Magic is, why you would want to use it, what is weird about it compared to other tools. So yeah, Magic, there are people who like it, there are people who dislike it. Fortunately, we have multiple tools, Magic, KLayout. You can decide which one you enjoy most and stick with it. Magic has a very uncommon database structure, so people who are used to using commercial tools or KLayout are used to the idea of everything in your layout being an object. So you have your objects are rectangles and wires and instances. In Magic, most of it is it's designed to be sort of like painting on a mask, just like you would create a mask for the Foundry. It is like tessellating a plane, which means you're just taking your whole area and filling it with shapes. And I'll show you why that acts differently than an object-based layout. And in some ways, it's better. There are times in which that it works better. There are times in which it doesn't work as well. It has its strengths and weaknesses. Many of the methods in Magic will seem a bit outdated. A lot of them, the Magic itself dates back to the 1980s, and between the 1980s and 1990s, there were Foundry processes and a set of open source PDKs called SCMOS, Scalable CMOS, based around the idea that you could make a layout in a non-physical geometry in, quote, lambda units, and that you could just scale that to different sizes. The SCMOS has not been practical for many years, but you'll see things in Magic that definitely relate back to that style of doing layout. Magic is very command line driven, and it has a GUI on top of it. You will do your layout by working in the GUI, but a lot of times that you will just be typing commands into a console. It is based on a Tickle interpreter, so if you've been using Xscheme, you will be very familiar with the Tickle interpreter sitting at the bottom. Unlike Xscheme, where you can do your entire schematic in Xscheme GUI without ever touching the interpreter, in Magic, you are almost certainly going to end up needing to use commands and typing them into the console. And for that, once again, Harold Prettle, who did the OSIC multi-tools, if you go into that OSIC multi-tool repository, there is a directory up at the top called Magic Cheat Sheet. And if you click there, you'll find Magic Cheat Sheet.pdf, and that is a nice summary of the main commands that you may need to use in Magic, as well as a summary of, sorry, that's more commands, the main keystrokes that you need to use. So it's a very good guideline. You'll probably want to keep this thing handy while you learn to use Magic. So also for learning Magic, the best thing to find is video tutorials. There are a lot of good video tutorials. I went to YouTube and I typed in to the search window Magic VLSI, and I came up with a lot of good, all the best ones that I know about. And plus, I'm always surprised every time I do this, I find videos out there that I've never heard of before. People are using Magic and making video tutorials. Try them out. So the ones that I recommend are the ones by Brad Minch. Down here, I think there's here where you see it says B Minch. That's one of Brad's tutorials. Karsten Wolf has a lot of good tutorials as well. And then eFabulous, we have produced several video tutorials. Like this one is probably the best with Matt Vinn and me doing layout is exactly what I would like to spend an hour in the middle of this tutorial going to, but won't have time to. So go take a look at that, the op-amp analog layout. I think this is very relevant to the kinds of IPs that will be created for the Chipalooza challenge. And the online documentation I already went through, that's from the opencircuitdesign.com. And for the command line reference, there is of course, the cheat sheet, but then if you want the full set of commands, you'll find that on the Open Circuit Design website. So getting up and running with Magic. You can invoke Magic from the command line on Linux with Magic, give it -D for a graphics mode, and then you will need to tell it where to find the PDK. That ends up being a relatively long command line, and so what I always do is I create an alias in my login file. So if I type alias, the name that I gave to it, that's arbitrary. I call it Magic Sky for my favorite invocation with the Skywater PDK, and that is the command line that is attached to that alias. It does magic-dogl. That's an OpenGL graphics. I like that much better than the default X11 graphics. And then this points to the path that I installed the PDK in. Here I wrote it as PDK root. A lot of the tools expect a environment variable called PDK root. If you have that set, you can use that in the command line as well. And then if you want to immediately load in a cell, you can give the cell name on the command line. There's also a batch mode. The batch mode is usually restricted just to doing extraction and DRC, but if you have a script, and if I get around to it in this webinar, then I will show you where you can find some of those scripts, is to do magic-d null, meaning no graphics for this, no console for this either. You still need to tell it where the PDK is, and then you can pass it the name of the script. All right, so let's start Magic. So I'm going to start Magic with the alias that I gave it, Magic Sky. And Magic comes up looking like this. It is a very minimalist layout. That's just the way I like to do layout, is to have as much space as possible for viewing the layout and as little space taken up by everything else. I'm going to shrink this a little bit so I can look at the list of things I wanted to go through. All right, cursor box. So Magic has two ways of dealing with figuring out where it is on the layout. One is where your pointer is, and the other is something unique to Magic called the cursor box. And that is a box that you just place on the layout, and if you move around the layout, then the cursor box stays put, even though your pointer is moving around on the layout. And you use that cursor box to tell it to do some action inside that box. So, for instance, if I want to paint a rectangle in that box, then now we get to the idea of its plain database has the idea of painting and erasing as opposed to creating and deleting objects. So I'm going to paint into this box. So I will go over to my list of layers on the side. I'll find like metal 1. Here's metal 1. If I want to paint into the box, I use the middle mouse button. I click the middle mouse button and I paint. That's make that a little bigger so it's not showing a DRC error. And the other way, if I don't want to go over and find the layer, if I have a layer in my layout already, I can do the same thing. I can go put a box where I want to paint something. I go over and I find that same layer that I want to paint, and I click the middle mouse button on it, and it paints it into the box. So that shows you can use the box along with the pointer to do certain things very efficiently. Now, when I first drew it, it was too small. You may have seen a bunch of little white dots come up on the screen. That is a DRC error. So Magic has an interactive DRC. This is another really nice feature of Magic, is that it gives you immediate feedback on DRC errors. So what it's telling me here is two different errors. Over here, I am not wide enough on my metal 1, and that's what it's telling me. I'm not wide enough. If you want to see what the DRC error is, you can go click anywhere around that error and type a question mark, and it will say here, metal 1 width is less than 0.14 microns. So it's telling me I've got an error. And here's a different error. It's a spacing error. So if I press question mark on that, it's telling me my metal 1 spacing is less than 0.14. But here's what I really like about the interactive DRC. Not only is it telling me immediately when I have an error, but it's also telling me exactly where the error is. So if I want to fix this error, I know all I need to do is paint more metal 1 here out to the limit of that error, and that will be enough to solve it. And likewise, if I want to solve the error of spacing, I only need to erase as much metal out to the limit that it is showing me the error, like this. So to erase something, it's just like painting, except I want to paint space. So I put my pointer over top some area of space and I click the middle mouse button. That's just like erasing. And by erasing just to the limit of the DRC error, I've solved the DRC error. Really easy to do, helps make layout right the first time rather than doing layout and then finding out what all your DRC errors are. Another nice little feature of Magic is its ability to do wiring. So I've got this crosshair cursor right now. That is called the box tool, and that's what allows me to go draw this cursor box around using the mouse buttons. If I want to draw a wire, I can, let's say I want to have a wire that is 0.2 microns wide. I'm going to manipulate this with a command. I'm going to type box width 0.2 microns. Now I have a 0.2 micron wide rectangle. That is maybe a little bit too short. So I'm going to make it a little bit bigger, make sure the width is 0.2. And I'm going to, let's say I want it in metal 3. So I'm going to fill that with metal 3. Oh, no. 0.2 is too small for metal 3. Let's go with 0.35. Okay, there we go. Now I still got an error. If you want to know what this error is, it's telling me that the metal 3 minimum area is too small, but I'm going to extend this as a wire pretty soon, so it doesn't matter. So I'm going to go to the wire tool, press the space bar. The space bar switches between tools. So I can go from the box tool now, press the space bar once, I'm in the wiring tool. That just changes all the key bindings of the mouse buttons so that now when I use the mouse buttons, I can do wiring. If I want to get back to the box tool, I can cycle through the different tools with the space bar. So there are a couple other tools, a pick tool. This goes back to the box tool. Once again, I come back to the wiring tool. With the wiring tool, I can find the type of material I want to create a wire out of. I click on it. And you can see it says, if you can see that, it's probably a little small for the video, but using metal 3 wires, 70 units wide, from here I can extend my wire out and interactively create the wire. So I can click, mouse button, click, and create a wiring path. If I want,
maximize the window so that people can see it clearly.
I can do that. Well, I can't make the console window any bigger. I can make the layout window bigger.
Yeah, that's perfect.
Now, if I want to, say, go up a layer, I can click on Shift and left mouse button, and that takes me up a layer. If I go Shift and right mouse button, that takes me down a layer. So Shift down a layer, down to metal 2, Shift down to metal 1, Shift down to local interconnect. So this is the easiest way to connect everything together in a layout. And between that and the parameterized cells, I think is...
Luke asked, what is a unit in length?
That is... I was going to get to that on the next page. I can do that quickly right now, and I'll just skip it when I get to the next page. When you start out, no, let me wait until I get to the next page. I promise I will go through that in just a minute. And there's a reason for that. So next thing I want to go through is ports and labels. So if I want to label, the best way to do a label is with the menu, edit, and text. And if I put down a box or I select a rectangle here, I can say I want to call this, I want to label this with text. I want the size of this to be 0.2 microns. And then I can say apply, and I've got my label. Now, if I want a label to be a port is important for making sure that the cell I'm working in is considered by Magic to be a subcell of the type that it will write a subcircuit into a netlist when it writes that cell. And when it writes that subcircuit, it will need to know what are the pins and what are their names and what order they're in. At least for creating the port initially, I can either select my label that I just made. I can go over here and tell it to enable the port. I get a number after that. That number is the order in which the port will be written out when it writes a subcircuit, when it extracts this layout into a netlist. So this will be the first pin, number 1. If I say apply, now I see that that label is turned from yellow, which is a normal layer, to blue, which is a port label. And so now that I have a port label in my layout, it considers this layout to be a subcircuit in the netlist. If I want to write GDS, the first thing I will need to do is name my cell. My cell by default is just unnamed. I can type like save test cell. And now my cell is named test cell. If I want to write that to GDS, I will just go to write GDS and put in a name, test cell.gds. It will automatically do it with GDS. So now I have a file here called test cell.gds. If I want to take something that I did in Magic and import it into KLayout, KLayout does read .mag files. I'm not sure it understands everything that Magic does when it generates GDS, so I would suggest porting between those two tools with GDS files. If I want to read that file back, I can say quit. I can start Magic again and just give it the test cell as the file name, and I got that cell back again. Search paths. So if I want to deal with a lot of cells and that's cluttering up my directory, I can put things in a subdirectory. The only thing is Magic needs to know where to find that subdirectory. So in this case, it does not automatically know where to find the subdirectory called param cells. So if I go to options, there's a library manager. What it does know about is where to find all sorts of, well, it knows where I am right now, which is my current directory, and it knows where to find all the things in the PDK. It doesn't have any other information. So what I will do is I will say add path. And in this directory, I've created a path called param cells and put some parameterized cells in it. So I'm going to say add path param cells. And now if I go back to my library manager, I think I might have had to do that before I went to the library manager. Let me do that once again really quickly. So add path, param cells, and then go to the library manager, and I have param cells. So now it understands that param cells is a place where it can pick up cells from. I can click on that and say place, and it places that cell in the middle of my layout. I could take that, I can use the M key, I can move it around. One thing some people have questions about is that they will load a layout and they will say, oh, I don't see anything in it, and that is because it is unexpanded. So that's what I am looking at here. I just placed a cell, it is unexpanded. All you need to do to expand cells is put your cursor over the background, type S, so you've selected the your whole layout, and then either type expand, use the X key, or there is a which one is this? Cell expand from the menu, and then that will show you what was inside the cells that was hidden before. That was that for that. So snap and grid. For the snapping grid, I want to go find another cell. So I'm going to go back to that library. Oh, I just popped it down. The library manager. And as I said, it has the standard cells in it. So let me go down to the HVL, high voltage library, and pick up like a buffer. Here's a buff size 2. I'm going to place that. And again, type X to expand. All right, here is a standard cell buffer. Now, the question that arose earlier about what are the units, I'm going to show you that if I try to place my box at the bottom corner of this, I cannot place the box at the bottom corner of this. The box is always at most halfway up to this. And the reason is because this box, if I type the B key, it's telling me that my box is size 0.01 microns. The minimum manufacturing grid for Sky 130 is 5 nanometers, 0.05 microns. The way to get there is to go to, what is it, window. Type snap to grid off. If I have done snap to grid off, now my minimum box size is the minimum manufacturing grid of Sky 130. That's 5 nanometers. If I type B for box, it is telling me, yes, I am at 0.005 microns. You can blame me for the choice of defaulting to 0.1 microns on startup, but at least that's the way you change it. There's also a command snap int, snap internal. So type snap internal or snap int for short. That will also do the same thing. That gets you to the minimum manufacturing grid. And the B command for box will tell you exactly what size your box is at any time. So I can always see the width and height, then it'll give me the width and height in microns. And I said there were some things that you could see vestiges of the scalable CMOS and lambda values. It will also tell you what your size is in lambda and what your size is in internal magic units. Now, other quirks of magic, contact areas. So here where I just pulled one of my parameter devices out. So if you look at a layout in KLayout or pretty much any other tool, contacts are always square. Contact cuts are required to be square. Contacts in Magic are not square. The reason is that contacts in Magics are effectively derived layers. So Magic does this for the purpose of being efficient when either viewing layout or when doing extraction or doing DRC. If it can represent an entire contact array as just a single box, that makes it a lot easier to do those things. So if I type, let me just put a little bit of local I, a little bit of metal 1, and then in the middle of that, I'm going to drop a via LI. That is just a giant contact array. Now, how do I see that? If I want to see the contact cuts, then there is a way to view what Magic is going to do when it creates the GDS, and that is to do this command called sifc, sif standing for Caltech Intermediate Format, which was popular once upon a time back in the 80s before GDS became popular. But I can say sifc, and I give it a layer name, which is something SIF uses as layer names instead of the layer purpose numbers that GDS uses. And for contacts, that's CONT, and that shows me where the contact cuts are in here. And for local interconnect to metal 1, it's a MCON is the term for it in Sky 130. So that shows me where all the contact cuts in this array are. So that's how it deals, that's how Magic deals with contact cuts. And if I don't want to see these contact cuts anymore, I can go to, I think there's the layers, clear feedback will make them disappear, or the command feedback clear. Oops, here, spell it right. Other quirks of Magic. There are lots of derived layers and generated layers. So a derived layer is when it reads in GDS, it will take different layers and from the GDS layers and map them into its own derived layers. So for instance, this transistor is its own layer. It is not just poly over diffusion, but it has created its own layer here. And if I bring this up where you can see it. If I type what, it's saying that this is a type NNMOS, which is a native VT FET device. And so that's just a derived layer that means that this has various implants in it. So one of the implants is, I don't remember what the NVT implant is off the top of my head, but I do know that all NFETs are going to have in SDM. So if I do a sifc in SDM, that is the in implant layer. So that's a generated layer. That is what Magic is going to generate, just like the contact cuts. It's what Magic is going to generate when it writes GDS out. But in order to make the layout cleaner and so that you as the designer don't have to worry about all these implant layers, its presentation is going to be, I have this device type, and you don't worry about all the implant layers because Magic is going to write those itself when it writes GDS. Let me skip over annotating layout for a minute. One of the drawbacks of Magic generating its own layers is that if you take something like a vendor layout like this, and you read it directly into Magic as a .mag file, and you tell Magic to write it back out using its own generated layers, it's going to change things because it's creating all of these generated layers itself, and they might not match what's in the vendor cell. And that is definitely true of standard cells, because standard cells are designed just right so that all these cells can abut directly right at the edges, and there are all these layers that have to match across the boundaries from one standard cell to another. And so Magic has the idea of vendor GDS views. And what that means is that this cell is effectively an abstract view. What I'm looking at is a representation of something in Magic that has GDS data from, in this case, Skywater, but that is somewhere else. So if I use the greater than arrow to descend into this device, and I type property, this is a vendor cell because it has a property called GDS file, and that GDS file is pointing to something in the PDK path, which is the Sky 130 HVL library, and it has its own GDS file. And whenever Magic goes and writes this cell into GDS, it is going to rip the GDS data for that cell directly out of this file and put it into the output GDS. Normally, this is all transparent. And if you have the PDK installed in a system-wide directory, like I did when I installed it, it went into its default directory, which is user local share, then this thing comes up as not being editable. I cannot change this. And it says up at the top, not being edited. On some of these things, I believe, like the Docker containers, it goes into a home directory. And I am not sure if that home directory is writable, but if it is, then you need to be careful because you cannot change this layout. If you do change this layout, you are not really changing the layout because the layout is actually here in this file, not what you see on the screen. What you see on the screen is Magic's best representation of the file, and it looks right. But there are things like those implant layers that are going to change if you modify that file. And then it won't match the GDS data anymore. And then back to this annotating layout. So one way to make sure, so I said that this test had this is a port label, and it has associated with it a port index, which tells it what order to write in the spice. And if I don't know offhand, if I have created a layout, but I do not have the ports in order, I can automatically annotate over what I have written by reading in spice. And so I can just read in the netlist by saying read spice. I want to mention that because there are two different ways to read in spice. One of them comes from this import spice, which I'm going to show in a minute. This is the powerful one that will just pull an entire netlist into layout. This command called read spice is just an annotation. It is going to go read the netlist and make sure that all the labels I have in my layout match what it sees in the netlist and make sure that the port order is the same. So it's going to change all the port orders. This is a very common problem when doing simulations off of extracted netlists from layout is that the layout creates the subcircuit, and the subcircuit has a port order that is different from the schematic. And when it tries to run the simulation, it calls the instance with the wrong ports, and everything is scrambled up and the simulation doesn't work, and it's really hard to tell why. If you make sure that all of the ports are the same order in the layout as they are supposed to be in the simulation or in the schematic, then everything will work smoothly. So now,
couple questions, Tim.
sure.
First question is, can we do a generate from source where we drop P cells in from the window?
Yes, you can. I believe I had that in a later slide, but I'll show you how to do that right now. So I had this one I got by just reading it from where I created it before. But the PDK does have two menu items up here that are how you reach the generated cells. I put them into two different menu selections because otherwise the menu list gets really long. But you have MOSFETs, diodes, varactors, bipolars, you have resistors and memcaps and parallel plate capacitors.
Is there a way to do generate from source from a schematic?
That is just what I was about to demonstrate. So let me just do, since I was on that topic, let me go ahead and show that. So if you wanted to just create a NMOS from scratch manually, you can go to Devices 1, click on NMOS. One thing people want to know is where is the particular type of NMOS I wanted. In this case, and this is sort of a design choice I made when I was creating the generated devices for the Sky 130 PDK, but I decided to have one entry in the menu for NMOS, and then once you get to that, you can decide which device you want, and you can change it between your standard 1.8 volt NFET or your low VT NFET or your 5 volt tolerant NFET or your 5 volt native VT FET. So just choose which one you want. Like, okay, now I want the 5 volt tolerant. I can set my width 1 micron, set my length to 1 micron, and then I have all these other choices. So I say create, it just dropped it on top of my other one, so I will move it now. Again, it is unexpanded. I will type X to expand it, and there I have it. And the device inside, just like the one I was showing before, was called NNFET. This one is, I type what? This one is MV NMOS, which is the moderate voltage, middle voltage, meaning 3.3 to 5 volt NMOS transistor. So yeah, back to that complicated one. Let me quit out of here because I want to start this fresh in a new directory. So I'm going to come out of here. I'm going to create for myself a new directory and then start up Magic again. So this is how you get from a schematic directly into layout. Don't expect this to be doing floor planning or placement or routing. It is not that smart, but it will do the basic thing for you. So I click on Import Spice. This is something I did for case. So I've got the usual case-derived file structure in which it put things in netlist, schematic, and there's my Spice netlist for the device, for this IP. And when I say open, you'll see it's doing a lot of work now. So now it's actually looking through the file and creating all the devices. And then you wonder, why the heck did it come up looking like this? Well, the answer is that it has absolutely no idea, conception of how I intend to do the layout floor planning. So it just draws them as it reads them. And in this case, for instance, I have a very, very long FET. If I want to, this is a generated cell, just like the one I created from the menu. If I want to look at the cell, I can select that cell with the I key, select an instance, and then I type Control P to get the parameters for it. So now I can not only create the device from the menu, but I can also take a device and I can modify it. And so all it knew so far is what it read in the netlist, which was, all it really knew about it is width and length and number of fingers. So it knew that it had a device that was 1 micron wide, 0.5 microns long, and had 200 fingers. A 200 finger transistor with all the fingers in a row is not very convenient to a layout. So I'm going to change that to have 20 fingers and in 10 rows, like that. So I will preserve my 200 fingers, but now I will have it in a better aspect ratio. And I click on apply there. And now I have something that is going to be much easier to work with in layout. But this is an array. I probably want all these devices matched, so I probably want to add dummy devices. So I'm just going to increase my fingers to 22. So I've got a dummy device on each side and increase my rows to 12. However, bear in mind that as soon as I do that, this is going to break LVS unless I also put those dummy devices in my schematic. And I think for what I have here, my dummy devices are not in the schematic, so I would need to add them here. Likewise, this resistor is just a very long resistor. In a schematic, you do not want to type out, draw out a chain of 20 resistors. You'll just do one resistor and make it as long as you need to make it. I do not want a single 100 micron resistor here, so I'm going to change this from 100 microns to 10 microns, and I'm going to repeat it in X by 10. And now I've got a resistor that's a lot easier to work with. So once you have imported, that's what you'll do. You'll go through each of your devices and make sure that it is arranged properly, and then it's time to floor plan. You just take all of your devices and move them around where you need them to go. And then if you decide that what you chose is not good, that you would rather have 11 fingers with 24 rows, and then you can change that. So just that's the time in floor planning to adjust the arrays to be the right aspect ratio to get things in a way that you can make a nice compact layout out of it. Okay, I think that was, I've already gone through all these things. Yes, it uses the Sky 130 device generator, and you have to deal manually with all the properties that cannot be described within a schematic netlist, but apply only to layout. So I just show how to manipulate parameterized cells. The other thing you're going to want to manipulate is ports. So here where I have my import function is trying to do three things: preserve the hierarchy that you have in your schematic, your schematic, and preserve the ports that you have in your schematic, and preserve the devices that you have in your schematic. The schematic I just read in has no hierarchy, but if I did, then this process of reading in the subcells, creating ports, will be repeated for each of the cells in the hierarchy, and then those cells will be placed inside the other cells. So you'll have the whole hierarchy. It'll just be scrambled with everything, all the devices laid out in a row, and you're left to arrange them. Ports, just because, again, the import function has no idea what layer ports are supposed to be on. They, by default, all come up on metal 1 with a square. If you wanted to change layers, like say I want this VDD to be on metal 3, then the thing to do is just to paint my metal 3 below it. So here we go. I'm going to click on that to get my metal 3 layer. Now I'm going to select the layer. I'm going to type A for an area selection. I say what? I have my label. It says VDD is attached to metal 1. I'm going to use the set label command. I'm going to say set label layer metal 3. And now if I select this and say what, it says VDD is attached to metal 3. So now I can delete this metal 1, and I've got a port on metal 3 instead of metal 1. That's a little bit tedious, but you shouldn't have that many ports that you have to deal with. You can go into the Magic command reference and look up the set label command to see all the things you can do. Mostly what you're going to want to mess with is either the box, which changes the shape of the label itself, or the layer. Those are the main things you'll need. And then for manipulating the cell hierarchy, hopefully you had the schematic the way you want it in the hierarchy. Magic will recreate that hierarchy. If you need different hierarchy, you can do things like, if you want to select a group of cells, I'm going to actually unexpand things so I can just find all the cells and do an area selection of them all at once. And I can say select save. And that will create a new hierarchy out of these cells. Then let's see, select save test cell. Then that test cell doesn't exist yet, so I would have to then delete all these things and then say get cell, test cell, and then I get my test cell back again. So I just created a new level of hierarchy in my layout. Again, you probably want, you probably have your hierarchy designed the way you want it in the schematic, and you probably don't need any extra hierarchy, but if you do, that's how you do it.
Does any of the modification you make in layout, or can it be annotated or back extracted into a schematic? So for example, the finger devices, is that visible in the schematic layout? Schematic annotation?
No, it is not. And the reason is because let's see, that would be a change between the M and the number of fingers. That would be like a trivial example. What we really need is a standardized method of how to annotate your schematic so that it has layout hints in it. That's something I've been thinking about. Something to work on one day. It's getting on close to 2 o'clock, so I will go through KLayout pretty quickly, and then I think I will leave all the stuff for extraction to the next workshop in 4 days. So let me pop down Magic and for KLayout. The hard part with KLayout is just running it the first time. Once you have attached it to the PDK, told it where to find the PDK, the rest of it is then easy. It saves all that stuff to your local directory, a .klayout directory, and so the next time you bring it up, it's still there. Let me delete my .klayout file. So it's not there. So this is like it will be if I first bring up KLayout. Let me do something else too, which is bring up Magic again, just so I can write the GDS of this file, since KLayout's going to want to see. Oh, no, not in this one. Sorry. Go back to my original directory. Load. This is the completed layout. I hadn't shown you that one yet, so I had already done that, created a layout. So I had done it that way. I had imported it using import spice, rearranged everything the way I wanted to make a nice layout. Now I'm going to write GDS. Just do that from here. File, write GDS, and IP Winstramp. Okay. Now I'll be able to see that in KLayout. So I'm going to run KLayout first without any arguments. And when it first comes up, this confused me for a long while. I can't get to anywhere. It looks like it's supposed to be about a technology, and it doesn't seem to do anything. Well, here's what you do. This is how you get started with the process in KLayout. I am going to start with going to Tools, which is a menu item in Manage Technologies. Then there is a white box on the left. It says Default Technology. The trick is to right-click into that and click on Import Technology. And when you import technology, then you need to know where your PDK has been installed. In my case, I am under user local share. So I can go user local share PDK, Sky130A, libs.tech, KLayout, and tech. And there is a sky130a.lyt file, and I'm going to open that. And then I hit OK. And now I have, in this default, I can click on this down arrow, and Sky130 is a choice I get. There is one issue that I probably need to track down and fix in the PDK, and that is that it does not have the layer mapping correct by default. So I need to go to Tools, go to Manage Technologies, open up the Sky130, go to General, and here's where it says Layer Properties. I'm going to change Sky130.lyp to Sky130a.lyp. Click OK. Now we start KLayout again, and I have got my Sky130K. It should know everything. If I do open, I can find the GDS that I just wrote, and there it is. And it's got all the right layers for Sky130. The one thing I cannot do here is I cannot edit anything. All I see is move and ruler. That was the other thing that got me confused for a while when I started using KLayout, is that if you want to edit, you need to do KLayout-E. So now I do KLayout-E. I've got all these tools to use. Now I'm going to go back and open again my GDS file. And this, I think this is more intuitive than Magic. And I think people who are used to commercial tools will find this much easier to get used to. If I want to move something, I just click on Move. I can click on the object and move it. If I want to do a path, the only thing to know is that it allows all angle paths by default. So I want to go to Editor Options, Basic Editing, and make sure that I've restricted my movements to Manhattan, and then I can go to Path. I can click on here. I think by default, I'm going to be on some odd layer like PR boundary. So I'll delete that. Let me go back to selecting a useful layer to draw with, like Metal 1, and go back to Path and draw my path. And I single click to add a link to the path, and then I double click to end. And again, I can move. And all of this is pretty intuitive. I'm not going to go through too much with KLayout. All right, that's what I did. Move objects, creating paths. Those are some of the main things you need to know. KLayout does have a whole parameterized cell system. That is complicated to describe, and we are at the top of the hour, so I'm going to point you to this repository that was just made by Leo Moser. The URL for this is codeberg.org/mol99 klayout-sky130-inverter. And if you go to that, it has a README file that gives you instructions on how to get KLayout working with its parameterized cells and how to make the parameterized cells and common issues that you're likely to run into. And as you can see from this picture, if you go through this little tutorial, you should be able to make yourself a little inverter with parameterized cells from KLayout. So I'm not going to go through that, but I recommend this little tutorial to get yourself up and running with parameterized devices in KLayout. And I went through this briefly earlier, and I said I was going to leave extraction for the next workshop. So it being the top of the hour, I'm going to allow, I guess, a little extra few minutes for some additional questions and answers. But otherwise, I am going to say that we'll see you at the next workshop, which is going to be the workshop number 3 on physical verification. It's now going to include extraction. So extraction, DRC, and LVS. There will be a post by email on the workshop, which is in 4 days, April 1. It will also be posted on LinkedIn, and I will put a link to it in the Chipalooza channel on our Slack workspace. So, Andy, any major questions that I can answer in the next?
I would start at the bottom of the questions list, and I think you can probably knock out 4 or 5 of them pretty quickly.
Okay.
So first one is, can we import the .spice into KLayout?
Not that I know of. If anybody knows differently, please post that so that I'm not giving out wrong information. But as far as I know, there is no automatic spice to layout conversion in KLayout.
Can I get by completely with Magic, or do I have to use KLayout for something?
There will be a DRC deck that is very important, I think, to run in KLayout, just to make sure that you have got the complete DRC deck. I'll go over that on the next workshop. Other than that, yes, you can work completely in Magic.
Or alternatively, you could work completely in KLayout.
Alternatively, you can work completely in KLayout.
Yeah.
As long as the only requirement for us is that we get valid GDS for the project.
Yep. Thanks for the workshop. Can we get the presentation slides? Absolutely.
Yes, I always make up the presentation slides and post them probably within the hour.
Are there automated scripts for metal fill?
There are automated scripts for metal fill, and I assume you're talking about pattern fill. I'll take that as an indication to go over that in the next workshop. That takes a little bit of talking through. So,
how does one decide between KLayout and Magic, and where can we get the best KLayout video?
There are videos posted on in the KLayout documentation. If I recall, I probably ought to defer to somebody else for which videos are the best videos, but there are, quote, official videos that you can reach from the KLayout documentation webpage, and those are probably the ones to start with.
Okay.
There was another question there. What was that?
Best KLayout video, and that was it. I mean, I think you covered it.
Okay.
Are device layout P-cell generators available in KLayout similar to those in Magic?
Yes, and that's what this tutorial that I pointed to you to on codeberg.org will be. And if you didn't catch this URL, then you can get it from the slides as soon as I post them.
It's actually hidden behind the banner on your screen. Can you move that window down very slightly, just so it's
visible? I'm sorry. Yes, like there.
There you go. Thank you.
Okay.
That's it. I think the rest of them are pretty well covered.
Okay, and as usual, I'm always answering questions on the open source PDK Slack workspace. In the best place right now is the Chipalooza channel, although I also regularly watch the Analog Design channel. Both are good places to ask questions. There are also specific channels for Magic and for KLayout. There's a specific channel for LVS. So, pick your topic, pick your channel. I'll find it one way or the other.
Andrew was pointing out in the chat that the next webinar is April 1st at 10 a.m. PT.
Okay, 10 a.m. Pacific Daylight Time, and we will get out that information soon.
Thank you very much, Tim.
All right, so other than that, I will say thank you for joining, and I hope you got the information you needed out of it, and I will see you for the last of the workshops in 4 days. Take care, everybody.